Hi everyone, this is Shanthamathi KS, Assistant Professor of EC Department from Ganadapati Tulasi's Jain Engineering College. So in this presentation, let's see about superheterodyne receiver. So first let us see what are the functions of that receiver. So the main function of that receiver is demodulating the incoming modulated signal. And the second step, that is we have to tune the carrier frequency, that is to select the desired signal. And next is filtering, that is to separate the desired signal from other modulated signal. And the last one is amplification, that is to compensate the loss of the signal during transmission. So what is the definition for heterodyning? So heterodyning, it is the process of mixing of any two signals having different frequencies that will produce a signal with new frequency. So this is called as that heterodyning. I'm repeating, process of mixing of two signals having different frequencies to produce a signal with a new frequency. So this process is called as heterodyning. So now we'll see the general block diagram of superheterodyne receiver. So the first one here we'll be having the receiving antenna. This is followed by pre-selector, and that is followed by RF section, and that is followed by mixer. It is followed by bandpass filter, intermediate frequency amplifier, envelope detector, audio amplifier, and that is followed by speaker. And here this mixer is connected with this local oscillator. So the superheterodyne receiver, it comprises of 5 sections. The first section is RF section, second one is mixer section, third one is IF section, fourth one is detector section, and the last one is audio amplifier section. So we'll see the explanation of this block diagram in detail now. So first is RF section. So this RF section, so here the incoming waves, so this is the incoming waves. So the incoming waves are picked up by this receiving antenna, and this signal is getting amplified in RF section and tuned to carrier frequency of that incoming wave. Okay, so for this, the first step is pre-selector. So this pre-selector is nothing but a broad tuned bandpass filter with an adjustable center frequency, right? So this center frequency is tuned to the desired carrier frequency of that incoming signal, and it will reject, this pre-selector will reject the unwanted radio frequency called image frequency. Okay, and this also reduces noise bandwidth and allows useful information. Okay, so next RF amplifier. So we can use one or more amplifiers here, and depending on that desired sensitivity. So sensitivity means that is the ability of the receiver to detect the weakest possible signal and to amplify them. Okay, so based on the desired sensitivity, we can use more than one RF amplifier also. So at the end of the, that is at the output of this RF amplifier, we may get the desired signal. Okay, so that desired signal frequency, we can denote it as F suffix S. Okay, so now this RF section is followed by your mixer section. So this one. So the mixer section is also called as converter section. So this converter section, it is the combination of the mixer and the local oscillator. Mixer section is combination of mixer and the local oscillator. So this section only provides the heterodyning function. So here the incoming RF is converted to predetermined fixed intermediate signal, and that frequency will be less than the carrier frequency. So here the carrier and the sideband frequencies are translated from RF signal to the IF signal, but the envelope, the shape of that envelope remains the same. We can also call this mixer section as a first detector. So the common intermediate frequency what we use here is 455 kilohertz. So here the local oscillator is connected to the mixer, right? So the frequency from this local oscillator, we can denote it as f suffix f0, and this local oscillator frequency should be always greater than your signal frequency which is coming out from RF amplifier. Okay, so which means this local oscillator frequency is greater than your signal frequency. So the signal frequency plus your intermediate frequency will be your local oscillator frequency. Okay, so some other frequency also will be there, that is called as image signal frequency. So this image signal frequency is the sum of the signal frequency and twice the intermediate frequency. Again I am saying the image signal frequency is the sum of signal frequency and twice the intermediate frequency. Okay, so this mixture part, here tracking process is done. So here in which the local oscillator frequency follows or tracks this signal frequency to have a correct frequency difference. So if this tracking process is not done precisely, some errors may occur. That errors are called tracking errors. Okay, so which means we may get multiple number of frequencies here, that is signal frequency alone we may get, oscillating frequency alone we may get, or we may get the combination of signal and oscillating frequency, and fourth one we may also get the difference of your oscillating and signal frequency. So out of these four frequencies, that is signal frequency, oscillating frequency, sum of signal and oscillating frequency, and difference of signal and oscillating frequency. So out of these four frequency, we'll be selecting only the difference of your local oscillating frequency and signal frequency. So this difference is called as the intermediate frequency. Okay, so now this mixer section is followed by the IF section. So this IF section comprises of band pass filter and intermediate frequency amplifier. So it is a high gain tuned amplifier, that is we will be amplifying that IF signal here. More than one IF stage is used in order to get good sensitivity, where we have seen already. So in order to improve the sensitivity, we can use more number of our amplifiers. Likewise here also, to improve that good sense, that is to improve that sensitivity, we can use more IF amplifier also. Next, coming to that detector section. So this detector section, it is the output of that IF section is applied to a demodulator which recovers the baseband signal. So this detector is called as an audio detector, and we can also call this as a second detector, whereas the first detector is the mixer section and this envelope detector will be acting as a second detector because the information signals are in the audio frequency. So this detector section is followed by your audio amplifier section, and here it will amplify audio frequency signal and apply it to the loudspeaker. So this section comprises of several cascaded audio amplifier, which means, and contains one or more speaker also. Okay, and here this local oscillator and pre-selector are ganged together. So this gang tunings, which means simultaneous tuning of tuned circuits, in all the RF amplifier stage, in which all the capacitance, see this capacitance, one capacitance, and here also one capacitance. So all the capacitance are ganged together and operated by one control knob. This is called as gang capacitance tuning. Okay, so next we'll see that advantages. So the first one is high sensitivity. We know what is sensitivity. That is ability of the receiver to detect the weakest possible signal and to amplify them. Next, here we'll be getting high selectivity also. That is, it is used to measure the ability of the receiver to select a signal of a desired frequency while reject all the others. That is, we'll be selecting only the desired frequency and will be rejecting other frequency signals. And third one is high adjacent channel rejection we have here, and the stability will be improved a lot, and will be having uniform bandwidth because we use a fixed intermediate frequency, right? So here we are using 455 kilohertz. So since we are using the fixed intermediate frequency, the bandwidth will what we'll maintain will be in uniform. Okay, Thank you.